Good evening, everyone. Myself, Rashika Agarwal, a registration number 20BCE1342, a BTech third year student in computer science and currently studying at VIT Chennai. Today, I'm going to present on a topic that is implementing keys and addresses in Python. So basically, what is a Bitcoin address generation in Python? So Bitcoin is a digital currency which was created in January 2009. It follows the idea set out in a white paper by a mysterious and pseudonymous developer Satoshi Nakamoto. A Bitcoin address is a unique identifier that serves as a virtual location where the cryptocurrency can be sent or held. Transactions provide to transfer assets between Bitcoin wallets that keeps private key and Bitcoin addresses. So the private key ensures that the transaction comes from a owner of the wallet. Generating Bitcoin addresses offline is also possible, and the code explains how we can generate a Bitcoin address and a private key step by step. So there are some operations for this. So, before starting to the operations, we will first ensure what is an Ethereum address. So, while signing to any platform on the internet, we first need a combination of a username and a password. So, we can think a Ethereum address as a username and its private key as the password. And using this combination of address and private key, it lets us interact with the Ethereum blockchain. An Ethereum address is your identity on the blockchain, and it looks like this number. An Ethereum address is public and it can be shared, but the private key it is secret and it cannot be shared. Ethereum addresses are generated using private key, and this is a process of how Ethereum address and private key is generated. So first we will generate a random private key of 64 or characters or 256 bits, which consists of 32 bytes. And this is a random private key. And after this private key is generated, we will generate a public key which is derived from this private key. And this public key is of 128 characters, 512 bits, which constitutes of 64 bytes. And by using a elliptical curve digital signature algorithm, ECDSA algorithm. So after applying something ACDSA algorithm on this private key, we will get this public key. And then we will apply a SHA hash function on this public key to make it a 64 character or 32 byte hash string. And the last 40 characters of the 20 bytes is prefixed with 0x, and when it is prefixed with 0, then it is called Ethereum address. So this is basically an Ethereum address. So for generating this Ethereum address and all, we need a Web3 PY library, which is a Python library, and it helps us to interact with Ethereum blockchain. So using Web3, one can make backend clients for their decentralized applications to handle interactions with blockchain, or reading data from it, writing transactions, or executing smart logic contracts. So this original API was developed from Web3.js, which is a JavaScript API, but it has improved with time to better serve and cater to Python developers' needs and demands. So now generating an Ethereum address in Python. So our first step would be to check if Python is installed in our system or not. We can check this by typing this Python version command in our terminal or command prompt. If we will use Web3 PY, a Python library, which is used to interact with Ethereum. So now we will install Web3 PY using pip command in our terminal or command prompt. So after setting Python PY library, Python and other library versions sometimes cause some installation problems. And if you face any such problems, then we can try setting these in a virtual environment or troubleshoot the Web3 PY installation. And if everything goes right, then Web3 will be installed in our system. So now we have to create a Python file, and it should be, we can name it any name, but it's better recommended to name it as address.py. So in this code, this is the code for generating public key, private key, and the address. So from the account here, the first line says that from the ETH account, which is a module of Web3, we are importing account, and the next line we are also importing secret module, which will help us to generate the random hexadecimal strings. Now, after generating this random hexadecimal string of 32 bytes or 64 characters, we are storing it in a variable named pri. Now, we will attach 0 prefix to our 64 character hexadecimal string, and we will store it in another variable named private key. So, this is basically our private key. Now we will print this private key with a message that save this private key, but do not share this because it's a secret key. It should only be known to the user, not to others. Now from this private key, we will generate our account address. So after printing the private key with the warning, we will create a new account using private key and store it in a variable named account. Now after creating the account variable, we will print the address of this account stored in ACCT variable with a string address. So after executing this file, we will see an output like this. Like first, it will print save, but do not share this, and then the private key, and then address of this private key. Thank you so much.